Good day. I am Mikel Gomez, and for my seventh laboratory exercise in data communications and networking, we will not use Cisco Packet Tracer. So that is quite a first as for this course. As usually, whenever I make these YouTube videos, I always have Cisco Packet Tracer with me. But for this particular exercise, we won't use it because all we need to do is to calculate or calculate and convert the following given IP addresses in the lab module to binary and or decimal. And yes, so that is what we will do for this one. So the first item asks us to convert the IP address 201.17.29.4 into binary. So how does that work? So a binary number is composed of eight zeros over here, eight digits over here, which may only read 0 or 1. And if it reads 1, that means it is true. So how it works is that we read from left to right, and we only count the digits that read 1 or true. So these digits always come in powers of 2. So for example, this is 1, 2, 4, 8, 16, 32, 64, and 128. So that is how we read binary numbers. So we add all the ones in the binary numbers, and what we get there is, yeah, that is how we do it. So let's start with this first one. 201.17.29.4. So how does this work? So converting 201 into binary results in 11001001. Why? Because as I said a while ago, this is 1, and since this is true, we will mark it as 1. 4 is not true. 2 is not true. 4 is not true. 8 is true, which is why it's 1. 16 is not true, so it's 0. Then 32 is not true, so it's 0. 64 and 128 are true, so they are both 1. Now let us put this on the calculator. So 128, hold on, 128 plus 64 plus 8 plus 1. And there we have it, 201. So our first item is correct. The first part of our IP address. Now for the second part, which is 17. So as we can see, only one and 16 are marked as true. So that is correct. So 16 plus 1, well, that's obviously 17. So there we go. Then now here, for 29, 1, 4, 8, and 16 are marked. So obviously that will lead us to 29. But for checking purposes, we will type it on the calculator. So 16 plus 8 plus 4 plus 1. And there we go. And finally, for the last part of our IP address, which is the 4 over here, only 4 is marked, so this the only one digit over here is the one at the 4 region. So on we move to number 2, is 192.168.1.1. So here our 164 and our 120 our 128 and our 64 regions or digit regions are marked. So obviously 128 plus 64 is equal to 192. So that's for our first part. For the second part of our IP address, 168. So over here we can see that 128, 32, and 8 are the ones that are marked with digit 1. So 128. For checking, 128 plus 32 plus 8, and there we have 168. And for our third and fourth parts, which are both 1, all we need to do is mark the the rightmost digit with 1, while we maintain the other 7 digits in the binary code as 0 for both parts. So that concludes our part 2. Sorry, hold on. That concludes our second part for number 1, or our item B for number 1. Now item C, since parts 2, 3, and 4 of our IP address are all 0, we will just leave all 8 numerical areas of the binary code as 0, and we'll focus on this one, which is the first part, which reads 172. So 172, as we can see over here, the only parts that are marked 1 on the binary code are 128, 32, and we also have 8 and 4 marked over here. So let's check on the calculator to see if our answer is correct. 120, sorry, 128 plus 32 plus 8 plus 4. And there we have it, 172. So there we go. Now for our second item. Convert the decimal, the binary number 11001110001100111010 and 101000000 to decimal number. So as we can see, the binary this binary number is divided into 4 parts to represent our IP address. And so we have to convert each individual section into a decimal number and piece them together in order to decipher our IP address. So let's first start with this one. In the first section of our binary number, we can see that 128, 64, and then all the rightmost digits from 1 to 8 are marked as 1. So all we have to do is check to see if it is correct. The decimal answer, which is 207. So 128 plus 64 plus 8 plus 4 plus 2 plus 1, and 207 is correct. And for this one, our second part, which is the 3 ones over here, so we don't need to calculate this. 1 plus 2 plus 4 is obviously equal to 7, so that is it. And for our third part, which is 26 over here, what is marked as 1 on the binary code is are 16, 8, and 4. So 16 plus 8 is equal to 24. Wait, no, 16, 1, 2, 4, 8, 16. Oh, sorry, 16, 8, and 2 are the ones that are marked, not 16, 8, and 4. So 16 plus 8 is 24, plus 2 is equal to 26. And then for the final part in our binary code, the fourth part of our IP address, 60 is our decimal number, so we'll check if that is correct. And as we can see, 160, sorry, I will correct that later. 160 is our binary address. So 128 plus, yeah, there's a wrong writing here. I will correct that later. 128 plus 32 is equal to 160. So that is correct. 160 is our the final part, or the of our binary number. So the decimal equivalent is 207.7.26.160. That is our IP address for our second item. So for the third item, there are 4 questions being asked. The first is, what is the network address 192.168.1.1 in binary? And obviously, the answer is what we came up with in item B of number 1, which is that binary number. And then the subnet mask 255.255.255.0 in binary. And the answer is basically all of these ones are available, and only the last part is in 0. So why? Why is that? Well, let us add all of the numbers. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that leads us to the answer 255. And yes, so since all three parts, since the first three parts of our subnet mask are all ones, then the subnet mask will be 255, 255, 255, and 0. And this leads us to our C, our third question in question number 3. So what is the prefix length or the number of 1 bits um, in our IP address, or sorry, in our subnet mask? So the prefix length is 24, since each binary code is comprised of 8 bits or 8 digits. So since all 8 are 1, all 8 digits of the first 3 parts of our subnet mask are 1. This means that our prefix length is /24. So finally, we have the question D, which asks us to underline the network portion of our network address 192.168.1.1 and encircle the host portion. So as we can see down below, 192.168.1, the first 3 parts of our network address are underlined. That's our network portion, and point 1 is our host portion, one of the rightmost part. And we will tackle right now why that is the case. So, why did we do this activity? That is the first question on our evaluation over here. So, why do we need to convert the decimal value to binary numbers? So, why did we do this activity? So, computers operate using binary ones and zeros because they rely on transistors that switch on or off states. So, being able to convert our decimal numbers, which are the numbers we use in real life, into binary numbers will help the computer understand and interpret the numbers in order to process the data on the network efficiently. Now, why do all computing devices have an IP address? Is it possible to have a similar address among end devices? Well, the IP address, as I've already answered a similar question in one of my previous YouTube videos, previous laboratory exercise, and I basically related or compared that IP address to an email address, since every device connected to a network requires a unique IP address for identification and communication. So, like an email address, as I said in that video, having the same IP address can lead to conflicts, making it impossible for devices to send or receive data correctly. But, however, there is a let us say a loophole in this scenario. So there are cases where similar private IP addresses are present on different networks. However, this applies only to different networks, as in the same network, two devices may not have the same IP address. So, with that being settled, let us go to number 3, the subnet mask. We calculated this a while ago, and now we are asked its importance. So as we could see a while ago, the first 3 parts of the subnet mask were all one, while the last part of the subnet mask was zero. And the reason why it was like that is because the subnet mask helps in defining the network and host portions of an IP address, allowing devices to understand which part of the IP address is used for network identification and which part is for the host. So, as we identified a while ago, our network portion and host address over here, the first 3 parts of our IP address are the network portion, and the last part is the host. So our subnet mask basically clarifies that. So whatever value we have in our network address, as long as it is not zero, the subnet mask will mark it as all one in our binary code. So 111, or 8 ones for the first 3 parts. Always remember, the first 3 parts of the IP address are the network portion, while the last part is the host. So that is how the subnet mask works. So yes. Now let's move on to number 4. So wait, why did we do that for the subnet mask? Well, it is crucial for routing and organizing IP addresses efficiently within networks. Okay, so now we can finally move on to our conclusion. So, in this activity, I can conclude that understanding how IP addresses and subnet masks work is essential for managing network communication and ensuring efficient data transfer. So, basic mathematics, in order being able to translate our decimal numbers into binary numbers will help us improve network communication as we are assisting our computers, even though they are computers, obviously. It is still our responsibility to program them wisely in order to make sure that the data transferring process works in the right and the most efficient manner. So that is all for the seventh laboratory exercise. Thank you for watching, and once again, have a great day.